Hello students, today's lecture is on bone remodeling, and we're just continuing our lecture series. In bone remodeling, this is a process that occurs throughout adulthood, throughout your life. It turns out that actually on a weekly basis you turn over about 7% of your bone mass. Again, remember, bone is a very active tissue. It's alive and it's very active, and it occurs, and this remodeling is an important process that occurs throughout your adulthood. Now, the point of this, the bone remodeling, part of the point of the bone remodeling, the key point, is that we have to maintain calcium levels in the bloodstream. That's very important. It turns out calcium is necessary for a lot of different systems, and as we get further into this semester, we'll see its importance. Calcium is necessary for the nervous system to work. It's necessary for the muscle system to work. It's also involved in the circulatory system and blood coagulation, and finally in cell division and growth. And so the body works very hard to maintain the correct blood calcium levels. And it does this by maintaining a balance between the calcium in the bone and the calcium in the blood. So that if blood calcium levels drop too far, then what will happen is the body will take calcium out of the bone and put it into the blood. And then if there is excess calcium, if there's more calcium than we need in the blood, then the body will take calcium out of the blood and put it into the bone. And this bone remodeling and this control of blood calcium, it's under hormonal control, and the two hormones involved, the key hormone involved is parathyroid hormone. And parathyroid hormone is secreted by the parathyroid glands. The other hormone that's involved to a lesser extent is calcitonin, and calcitonin is secreted by the thyroid gland. And this is an example of negative feedback and of homeostasis. If you remember in one of the very first lectures, we talked about homeostasis, the fact that the body is going to maintain certain physiological parameters, certain key components of physiological systems, will keep them within certain parameters, with a certain range, a certain variable range. We talked about like blood glucose, for example, or blood pressure or blood volume. Well, it turns out this is also a homeostatic mechanism. It uses negative feedback, and the parameter we're trying to control is blood calcium levels. So let's take a look at that. So here we have, let's take the case where we have a drop in the blood calcium levels. If we have a drop in the blood calcium levels, that will be sensed by the parathyroid glands, and the parathyroid glands will release parathyroid hormone. The parathyroid hormone, it will then stimulate the osteoclast, and the osteoclast will degrade the bone matrix and release calcium into the bloodstream, and that will cause blood calcium levels to go up. Classic example of negative feedback, where the initial stimulus, the drop in blood calcium levels, is changed in the end by an increase in blood calcium levels. So the stimulus, the response is opposite the stimulus. Let's just take another look at that. So here we have falling blood calcium levels. Blood calcium levels are getting too low. That stimulates the parathyroid glands. The parathyroid glands release parathyroid hormone. The parathyroid hormone stimulates the osteoclasts. And if you remember right, osteoclasts, they degrade bone matrix. They break bone down. As the osteoclasts break that bone down, that causes calcium to be released into the bloodstream, and that brings the blood calcium levels back to normal. So classic negative feedback loop that's controlling blood calcium. Now we could have it the other way. And this does not happen quite as often, but there's still a mechanism that is there. In this case, we have the blood calcium levels are too high. The blood calcium levels are getting too high. And so that stimulates the thyroid hormone to release calcitonin. Calcitonin then stimulates osteoblasts, and the osteoblasts will then take calcium out of the bloodstream and use it to build the bone up, and that ultimately will decrease blood calcium levels. Also a negative feedback loop, but going in the opposite direction. Thank you.